Start. I think it's recording. Yeah. All right, today's topic is related rates. This one's no calculator, but we are going to cheat a little bit if I have the answers up here. Oh, where are they? Is this it? This is it right here. Perfect. Yeah. And I don't need those. All right. A cylindrical barrel with a diameter of 2 feet contains collected rainwater, as shown in the figure above. The water drains out through a valve, not shown, in the bottom of the barrel. The rate of change of the height h of the water in the barrel with respect to time is modeled by. So we have dh dt. It's represented by an equation where h is measured in feet and t is measured in seconds. The volume, and they give you the volume of a cylinder. So A, find the rate of change of the volume of water in the barrel with respect to time. So the rate of change of volume. So we're going to find dV dt equals something when the height of the water is 4 feet. When h is equal to 4. On a cylinder, as the water level decreases, the radius does not change. You can see the radius would stay exactly the same all the way to the time that it empties. Now, because the radius never changes, we can plug the value of the radius into the equation. So we can write V is equal to pi times 1 squared h, because the radius is 1, the diameter is 2. So be careful with that, don't plug in 2. So the volume can be written as pi h because R never changes. Now, one of the problems on the worksheet has a cone. And so you have the height and you have the radius. Height and radius. And as the cone empties, the height's going to change and the radius is going to change. Now, the way that we fixed that, the way that we replaced variables when we did this, was we said R over H is equal to, let's say the cone was 10 feet high and the radius was 5. So then we'd do 5 over 10, and now we can manipulate that to replace variables. You could say R is 1/2 H, or you could say H is 2 times R, either one, whatever you had to use. So we use the fact that we have similar triangles with that. So you'll need that for the second problem today on the worksheet. All right, where are we? We're on letter A. We want dV dt when h is equal to 4. Oh, and we have dH dt here. So let's take the derivative of this, dV dt with respect to t, is equal to pi dH dt. And they tell us that h is 4. But we know what dH dt is. It happens to be this little expression. So we have pi times negative 1/10 square root of 4, because it says when h is equal to 4. So that's negative 2/10 pi. So that's negative pi over 5. And it's going to be, now what is this? Feet cubed per minute. Per second. Feet cubed per second. When the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing? So is the rate increasing or decreasing? So that's the derivative of the derivative. The rate of the height of the water. All right. Oops, I keep doing that. If I go off the edge here, it just moves everything. So we want d2h over dt squared is equal to, well, that's negative 1/10 h to the 1/2. So we have negative 1/20 h to the negative 1/2. But look at the bottom. We're taking the derivative with respect to t, not with respect to h. it says derivative of h with respect to t. So we have to multiply by dh dt because we didn't take the derivative of t. So we have to do this implicitly. We have to do the chain rule to get this. Negative 1/20th square root of h times negative 1/10 square root of h. Because that's what dh dt is. So it ends up being equal. I'm kind of running out of room here. 1 over 200 because the square root of h's are going to cancel out. Now that is greater than 0, so we can say increasing. Letter C, at time t equals 0 seconds, the height of the water is 5 feet. Use separation of variables to find an expression for h in terms of t. So we have to separate the variables. We're going to go 1 over square root of h dh is equal to negative 1/10 dt. So we're separating variables here to solve the equation. So integrate and integrate. Now that's h to the negative 1/2. So we have to add 2 halves, which is h to the 1/2 times 2 is equal to negative 1/10 t plus c. All right, so 2 square root of 5 is equal to negative 1/10 times 0 plus c. Now, of course, I know what 0 times negative 1/10 is, but usually one of the points is to show that you're using the initial value. I don't know how else we show it other than writing it down. So I am actually really good at multiplying by 0. You wouldn't believe I'm a total expert. Sarcasm, right? Write it down. I know what 0 times negative 1/10 is. All right, c equals 2 square root of 5. So now we're going to plug that back in up here. So 2 square root of h is equal to negative 1/10 t plus 2 square root of 5. But we got to get h by itself. So square root of h is equal to, if I multiply everything by 1/2, we get negative 1/20th t plus square root of 5. So h is equal to negative 1/20th t plus square root of 5 squared. So I didn't really want it for this. Yeah. For the next one, we're going to cheat a little bit. All right, rubric, real quick. 1 for the derivative, 1 for the answer. Pretty straightforward. 1 for the first part of the derivative, 1 for the second, answer with explanation. The explanation is just, that's the explanation right there. And then separation of variables, antiderivatives. This one's only worth 4 points because they say show that you use the initial point and then get the constant. They just made that all 1 point. And then 1 for the final answer. All right, this one. The inside of a funnel of height 10 inches has circular cross sections as shown in the figure above. At height h, the radius of the funnel is given by that little equation. And this is the equation of the radius because you can see as this would either fill up or drain, it's not really a linear type of relationship. It's got this curve to it. So that's going to change the equation a little bit. Find the average value of the radius of the funnel. Now this has nothing to do with related rates. It just, they're jamming in average value into this. So letter A, we got 1 over 10 minus 0, because we're going from 0 to 10. Of the integral from 0 to 10 of 1/20th 3 plus h squared dh. So we're trying to find the average value of the radius from 0 to 10. Well, you do the integral part. So 1 over 200, and then the antiderivative of 3 would be 3h plus 1/3 h to the third from 0 to 10. So 1 over 200, 30 plus 1,000 over 3. And then when we plug 0 in, we do get 0 for both of those. Be careful with plugging in 0 because it's not always 0. If in your equation had e to the h, plug in 0, get you 1, not 0. So be careful when you plug in 0. All right, let's finish this out. I don't finish these very often now, so we might as well do one here. 90 thirds plus 1,000 thirds. So we're looking at 1,090 over 600. So we could divide top and bottom by 10. So the answer the rubric gets is 109 over 60. And let's get inches, average value inches, because it's the average value of the radius. Radius is linear, so just inches. Like I said, this one really has nothing to do with related rates. Find the volume of the funnel. This one really isn't a related rate either. Actually, now that I think about it. This rate of change. Okay, C is a rate of change. All right. Find the volume of the funnel. I thought, well, how are we going to do this? Then I realized, well, if I took the area of that circle, area of this one, area of this one, area of this one, if we added up all the areas of all the circles, we end up getting volume. So we can't do just 100 or 1,000 or 1,000,000 or 1,000,000,000. We're doing that infinitely, and hopefully you realize that suggests integral. So we're adding up the area of all the circles from 0 to 10, which is pi r squared dh. Because r is in terms of h. So this is the integral from 0 to 10 of pi, and then 3 plus, let's do 1 over 400. I got to square the 1/20th also, so I squeeze out 1 over 400 in. 3 plus h squared squared dh. So that's going to give you the volume of this, whatever this thing is, funnel. So I'm going to go only so far with this because I don't want to stand up here and do arithmetic for 5 minutes. But this is how you would proceed on this one. 9 plus 6h squared plus h to the 4th dh. So you just have to multiply that out. Now I'm sure some of you might look for u substitution in there or all kinds of things, but if you just multiply it out, you just use the power rule. So pi over 400, 9h plus 2h to the 3rd plus 1/5 h to the 5th from 0 to 10. And this is where I'm going to skip to the answer. I'm going to give away the ending. 2209 pi over 40 is really what you end up getting. So we kind of skip to the end there. All right, finally we get to a related rate question. The funnel contains liquid that is draining from the bottom. At the instant when the height of the liquid is h equals 3 inches, the radius of the surface of the liquid is decreasing at a rate of 1/5. So the radius of the surface of the liquid is decreasing. So dr dt is equal to negative 1/5 because it says it's decreasing. At this instance, what's the rate of change of the height of the liquid? So they're asking for what is dh dt with respect to time. So now we need something that relates r and h. And we actually have that. That's sitting right here. This relates r and h. So dr dt is equal to, well, if we distributed the 120 through, we'd have 3 over 20. And the derivative of 3 over 20 is 0. Then we'd have 1/20th h squared. So that's going to be 1/10 h dh dt. So the derivative of that is 1/10 h, and then we're taking the derivative with respect to t. So we need that dh dt. We know dr dt, and we have the 1/10 when h is 3. So 3, and we're trying to find dh dt. All right, well, dh dt is equal to negative 1/5 times 10 thirds, so negative 2 thirds. And that's the height of the liquid with respect to time. So that's going to be inches per second. All right, give the next one a try. Let's see how far you can get. I'll give you a few minutes here, and then I'll catch up to you. If you're watching this video at home, just fast forward a little bit.
Okay.
So show the DH. Okay, so this is just take the derivative. It only gives us one number. The volume is changing at this rate, so the dV over dt. Okay, what else do we know? The radius can't change. And this, oh, okay. So the radius is we know dV dt.
Yes.
We know R. Okay. So you take the derivative of this. You get dV dt is equal to I R squared. It's 2 pi r. Yeah. Yeah, we use it, but we know R. Okay, so 2 pi r dh. Then pi dh dV dt is negative part pi square root h is equal to 10 pi dh over dt, and you divide over and you get negative h over because R is a constant. You don't do the power rule. Because this R doesn't come out. So this R squared has to stay, so that changes 25. And then this is 25 should divide over.
You do.
45.
So this is the same. Since radius is always 5. it's
Yeah.
5.
Yeah.
So we get, so we do for it's negative h, negative square root h. Do that wrong. Oh, we got integral. Pretty sick. Yeah. We get the TH over 1 over square h equals to 1 over You put the h's together and you put the t by itself. We just felt that one question. First question.
Yeah, I got the first part.
Each would you get it?
Whoops. New. So there's B. So C, to decide if the coffee pot is empty, you know, I mean, we're pouring and we see the liquid go out and it's empty, right? But we need something a little bit more mathematical than just vision. So how do we know when the pot is empty? When H is 0, right? When H is 0, when the height of the liquid is 0, there's no liquid in there. Or coffee, I guess I should say. So C, we're going to set the height equal to 0. So negative t over 10 plus square root of 17 squared. Well, squaring doesn't really affect zeros. So we could, well, you could square root both sides, I guess. But really, we need the inside to be 0 because 0 squared is 0. So t over 10 equals square root of 17. T equals 10 square root of 17. I think it's seconds, I think. Let's look at some multiple choice, just some various problems that I've chosen to look at. It seems like there's a chain rule on every single multiple choice I've ever seen. So chain rule, f prime of x is equal to, the outside function is actually squared, so 2 cosine of 3x minus 5. The next function is cosine, so times negative sine of 3x minus 5. And then the last is the 3x minus 5, so times 3. So if we multiply it all together, we get negative 6. And the only one that has negative 6 is letter D. And has the rest of the stuff too. So there's 3 functions in one, squared, cosine, and 3x minus 5. I picked the one to the right because it's probably way more simple than maybe you would make it. It's not U substitution. It's not integration by parts. It's just they're a little tricky in kind of separating a power into 2 powers. So this is t to the 2 halves times t to the 1 half. And when we multiply those together, we add the powers together. So this is the integral of 1 over t to the 3 halves. Now, they just could have said it's t to the 3 halves, but they wanted to try to trick you a little bit. dt, of course. So this is the integral of t to the negative 3 halves dt. Well, now it's all downhill from there because now we're just using the power rule. We're going to add 1. That's t to the negative 1 half times negative 2, then plus c, and that's exactly what they have. They don't go on to, put it down in the denominator. We go answer hunting at one point. We could go farther with it, but we have the answer already. The position of particle moving in the xy plane is given by the vector. We haven't talked about vectors for a long time. We will tomorrow, and then the third topic for this is going to be polar, where y is a twice differentiable function of t. At time t equals 1/2, what is the acceleration vector of the particle? And I thought this was an interesting way to ask this question. And I think we pretty easily can go from position to acceleration by doing derivative, except this one's a little tricky. So the velocity vector from the position vector is going to be 12t squared. I think we can all take that derivative. This one probably is a little harder in that we don't have a function for y. So the best we can do is say it's going to be y prime, leave the inside alone, not xt, and multiply times the derivative of the inside. So we do the chain rule. So they're jamming the chain rule into vectors. And then now we have to do this one more time. The acceleration is going to be 24t. And then the best we can do is constants tag along. Derivative of the outside, leave the inside alone, and then times the derivative of the inside. So there's the chain rule again, except now we're calling it the second derivative. They want this evaluated when t is equal to 1/2. So that's 12 comma 4 second derivative of 1, because half of 2 is 1. And that's actually right there. Clever little way to ask this. To what number does the series converge? And really it's saying what is the sum of the series? Because the series always converges to the sum. It never actually gets there. But if the sum is 4, it's converging to 4. So eventually it'll be 3.999999999. How many 9s do you need before you'd finally decide it's just 4? But it is always converging to it. Anyway, most of the time these are going to be geometric. AP loves putting geometric on here because they're usually pretty quick and fairly easy. Now this kind of looks like a mess. Now if you're not exactly sure what's going on, just write out a few terms. So everything to the 0 would be 1. Then when you plug 1 in, it'd be minus e over pi. Squaring both of those would be plus e squared over pi squared, and so on. You'd have e to the third over pi to the third. There we go, that's squared. Plus keep on going. So a sub 1 is 1, and we're multiplying by negative e over pi to get the next term. Now be careful if you have something like 2 over pi plus 2 over pi squared plus 2 over pi to the third. What's r? 1 over pi, not 2 over pi. The only way it'd be 2 over pi is if that was squared and that's to the third. Now r is 2 over pi. So be careful when you grab those constants. Sometimes they come along, sometimes they don't. So the sum, what this is converging to, whatever, it doesn't actually get there, is 1 over 1 plus e over pi, because we have the a sub 1 over 1 minus r. Now we have to go answer hunting. And they don't have this answer, but they multiply everything by pi. So pi over pi plus e. So there we go. Get rid of the complex fraction. We have not talked about logistic. This is kind of its own little topic that we have. And then we cover it in a section and we test it on the test. And then we don't really talk about it much. So the number of students in a cafeteria is modeled by the function p that satisfies a logistic differential equation, where t is the time in seconds and p of 0 is 25. What is the greatest rate of change in students per second of the number of students in the cafeteria? Well, like I've said, that this first part is kind of your exponential piece, exponential growth. And then this is the limiting factor on your growth. The closer the population gets to 200, the smaller that multiplier is going to be. And then when you eventually get to 200, you have no more growth because you're multiplying times 0. Now the population will grow the fastest when it's half the carrying capacity. So the rate at which the population is growing the fastest when the population is 100 in this case. So 200 minus 100. That should give you the biggest value of the rate. Well, 100 times 100 is 10,000. It's 4 zeros over 2,000. So we're looking at 5. I found one with actually related rates. A cube with edges of length x centimeters has volume, that, cubic centimeters. The volume is increasing at a constant rate of 40 cubic centimeters per minute. So what is the volume? So dV dt is equal to 40. That's what that number is saying. At the instant when x is equal to 2, what is the rate of change of x? So what is dx dt? That's what they're asking. In centimeters per minute with respect to time. So dV dt is equal to 3x dx dt. So 40 is equal to 3 times 2. And dx dt is what I'm trying to find. So dx dt is equal to 40 over, oh, did I do this wrong? 6, oh. What did I mess up? 3x squared, thank you. So that's over 12. So 10 thirds. There we go. Thanks for the help. Appreciate it. And then, like I said, our last topic for this quiz is going to be polar. So we're kind of getting ahead of the game a little bit. The area, well, let's read it. Let S be the region in the first quadrant bounded above by the graph of polar curve R equals cosine. And so they're telling you that this top curve is cosine. Now, it's not xy cosine, it's polar cosine. So it's actually a half a circle. Well, it's not even a half a circle, it's partial to that. Anyway, as a review, if we were to graph R equals cosine of theta, it's a circle with a diameter of 1 off to the right. Because cosine we relate with x, so it's off to the positive x side. So if we did R equals negative sine of theta, that would be down here with a diameter of 1, but sine's y, so it gets pushed down to the y side. If we plug 0 radians into cosine, we get 1 right there. Well, what do we plug in to get that? So in other words, what radians would we have to go to get a half a circle? Pi? It is not pi. When we graph these, I said 2 things finish in pi. Circles, and do you remember what the other one was? What else finishes in pi? Odd roses, right? Everything else finishes in 2 pi. Circles finish all the way around in pi. So from here would be 0. Over here is actually pi over 2. Well, think about it. What do you need the radius to be right here? I mean, the radius when we plug in 0 is 1. So the radius at 0 is all the way over here at 1. We need the radius to be 0 here. Well, what cosine of what gives you 0? Pi over 2 gives you 0. All right, anyway, so there's a little review of that. All right, what does it say? So we talked about cosine of theta and bounded below by the graph of the polar curve R equals 2 pi. Now they help you out a little bit because it says the region above is the cosine and the region below is the 2 theta. So they help you out a little bit so you don't really have to graph this to see which is which. They tell you. The 2 curves intersect when theta is 0.45. Wow, they're really nice to you because they're saying that this is 0.45 where they intersect. What is the area of S? The area of a polar graph is, I'll remind you, 1/2 integral from a to b of r squared d theta. Comes from the area of a sector. The area of a sector is 1/2 r squared theta. Well, our thetas are tiny little thetas. There's an infinite amount of them, and we add them all up. It's integral. All right, well, we're going to start here at 0 radians. We're going to work our way to 0.45. And those are following this bottom curve until we get to 0.45, and then it's going to change to following the circle. All of these are just kind of little areas that we're adding up, right? So we got 1/2 integral from 0 to 0.45, and that's going to be 4 theta squared d theta, because we're going to square r. So there's this bottom piece of it. I almost said half, but it's certainly not half. It's the bottom piece. Plus 1/2 integral 0.45 to, we talked about how that's pi over 2 to get to half a circle of cosine squared theta d theta. And it ends up, I mean, you use math number 9 for this, and it ends up being letter B.